So good day everyone. So for today's video, we're going to solve a problem solving about drying. So the first problem is about heat consumption per kilogram of moisture. So the problem is an industrial dryer processes the materials by heating intake air 10 degrees Celsius saturated to an intermediate temperature before it enters the dryer chamber. The goal is to remove 50 kg per hour of moisture. So the required is if the specific heat consumption is determined to be 3,500 kilojoules per kilogram of evaporated moisture, calculate the required heating coil capacity or kilowatts. So we have a given of T1 is equals to 10 degrees Celsius, M is equals to 50 kg per hour, H1 is equals to 3,500 kilojoules per kilogram. So the solution is to get QA in kilowatts. So we have a formula of QA is equals to H1 times M. So plug in the given. So we have 3,500 times 50. So calculate it so we can get a 175,000 kilogram per hour. So next is to get a kilowatt. So QA is equals to 175,000 kilojoules per hour times 1 hour over 3,600 seconds. So cancel out the hour so we can get a calculate it so we can get a 48.6 kilowatts. So the next problem is about exhaust fan impact on drying load. So a drying room for leather must be maintained at 100 degree Fahrenheit and 40% relative humidity. The room has a localized exhaust fan removing 1,500 CFM to carry away moisture. So the required is to calculate the gross humidification load or pound per hour added to the room slowly by this exhaust fan if the makeup enters at 20 degree Fahrenheit and 30% relative humidity. So we have a given of T1 is equals to 100 degree Fahrenheit with its relative humidity of 40%. So we have a CFM is equals to 1000, then H2 is equals to 20 degree Fahrenheit and their relative humidity is 30%. So the solution is we have M is equals to 15 times 60 over 14.5. So calculate it so we can get a 6,207 pound per hour. Next is to get the mass is equals to mx is times w1 minus w2. So plug in the given so we have a mass of 6,207 times the delta w which w1 minus w2. So we have 0.00160 minus 0.0006. So calculate it so can get a 1,005. So next is to get a CFM. So we need so we have 20,000 over 60. Calculate it so we can get a 50 CFM. So the last problem is we have a mushroom drying and latent gain. So the problem is mushroom dried in a room maintained at 120 degree Fahrenheit and 40% relative humidity. The process indicates a massive amount of moisture creating a high latent heat load with a sensible heat factor or CHF of 0.55. So the required is determine the slope of the room process line using the SHF protractor method in a psychometric chart. So we have a given of T1 is equals to 20 degree Fahrenheit and they have a relative humidity of 40%. So we have a SHT of 0.07, SHF is equals to 0.08. So the solution is, so we have a formula of delta H over delta W, so equals, plug in the be given, so we have 1060 over 1 minus 0.55. So calculate it, so we can get a 2356 BTU per pound. That's all. Thank you.